Hi everyone, this is Nataraj. I'm back with the other video. In this video, I'm going to talk about that mount the cloud storage bucket with GCP compute engine using Terraform. The GCP providing the simple and effective way to store and accessing the data from anywhere. In this video, we can mount the GCP bucket as a file system to that GCP VM. The Google Cloud Storage Fuse tool is an open source file system driver that allow you to mount the Google Cloud Storage bucket as a file system on Linux based operating systems. So in our case, we are going to install the Fuse tool in our VM. After that, we are mounting that our GCP bucket. Installing the Cloud Storage Fuse. In this URL, they providing the following instruction to installing the package. If you are performing the manual operation, then you can check it out this link. Architecture diagram. Using the Terraform, I'm going to provisioning that compute instance as well as the bucket. So once the provision is completed, I'm going to installing the Fuse tool using the shell script, and once the packages installation is completed, I'm going to mount the GCP bucket into that VM. So this entire operation I am performing with the Terraform. So we can see the code. Moving to the Visual Studio Code. Here at the Visual Studio Code, the entire code is available in my repository. You can clone from anytime. We can see the Terraform file one by one. The first one is that main.tf file, data blocks, the Terraform reading from the given data source and exporting the result to the given variable. So in my case, I'm fetching that operating systems. So I'm fetching from that Ubuntu operating system here. Next resource is that local blocks. The local blocks is to assigning that name to the expression. Its main purpose of this reducing the duplication with the Terraform code. In my case, that Google Cloud Compute instant resource, I used that local region in that zone parameter. Here I am concatenation of the both strings. So you no need to specify it separately for that -a zone value. Next resource is that TLS private key. It can generate the private key for your virtual machines. Next resource is that Google Compute address. It can allow to reserve that static IP address for your VM. Next resource is that random strings. The random string resource generating the random sequence of character with a given specific length and the characters. So in my case, I given the length is 8 and the upper and the special character will make it false. Next resource is that Google Storage Bucket. This resource creating that object systems. You can store that any types of object, either file or large binary types. Please note that the Google Cloud Storage is not a file systems, but you can mount the file to that VM and retrieve the file from the object for your VM itself. In the name parameter, I am calling the random strings, whichever I generated the 8 character. Here the concatenation is going on. Next parameter is that force underscore destroyed. This parameter destroying the bucket without error. This object or cannot able to recoverably. Next one is that uniform bucket level access. So here we are allowing to uniform control access to your object and all the bucket level rather than by managing the permission or individual object. The next resource is that data template file block. Here we are dynamically generated the configuration file based on that input parameter. The template file is start script tpl. I'll go into that tpl file. In this script, I'm adding that cloud storage fuse package source. Next command, I am importing the Google Cloud public key. Next, I'm updating the list of variables package and that installing that cloud storage fuse. Then I'm creating the folder to mount and mounting the folder with GCS packet. I'm moving back to the main.tf file. Next resource is that Google service account. Here I am creating the new service account for my project. Next resource is that Google Storage Bucket IMA member. This resource allow to managing the IMA policy and binding with that our GCP storage bucket. Here mainly who has what role. That is the concept here. Next resource is that Google Compute Engines. I'm creating the VM under the project ID which I have defined. The variable name of the VM I'm getting from that variable. The machine types are using the E2 micro. Zone already we discussed. The tag I'm assigning to that demo. The booting disk auto delete equal true, which means that whenever the instance is deleted, the same time the booting device also will be deleted. Next one is that initialized params. Here I am fetching that image value which is use of the data block. Next one is the labeling. I am assigning that label to my instance is Terraform. Next one is that network interface. Here I am assigning that my reserved IP whichever I created earlier, that reserved IP I am allocating to my VM. Next one is that service account. I am created that one of the new service account I am assigning here, and the scope value I provide with the privilege with storage read write. Next one is the metadata. So in our case we generated the SSH keys. I am creating the user called Umundu and I am calling that the keys whichever I generated earlier. Next one is that metadata startup script. Here I am templating file I am rendering here. So whatever the shell script written during the provisions of VM, it can installing it here. This is the depend on. So I am depending with that static IP as well as the bucketing part. Next resource is that Google Compute Firewall. Here I am opening the 22 port to the global network. Next one is that local file system template. Here I am generating that my public and private key and storing to my local machine. Next one is that output block. I am listing that my VM instant IP. Next one is that instant SSH key. This resource we can show that absolute path of the keys where located in my machine. Next one is the variable.tf file. This variable I defined with everywhere in the default value, so I am not providing with any separate Terraform variable.files. Next one is the provider.tf file. In this provider block, you can see the credentials. Here I am creating the separate service account. I provide the necessary permission to performing the Terraform activities. Next one is that git ignores. You can ignoring that files from while pushing that file to that repositories. We can moving to the terminal. We can execution this process. Going to the terminal. Now I am going to click on 3 dot. Click the new terminal. Now I am going to executing the Terraform init command to downloading all the dependency package. Now I am going to executing the plan command to validate my syntax. Yeah, syntax is okay. Then I am going to executing the Terraform apply command to provisioning my VM and as well as the bucket. Here you can see here the 10 resource going to added. So I am providing that user input is yes. Now the provision is going on. It takes some time to completing the provision. Yeah, Terraform operation created. In the output section you can see I think these are the instant IP address. Then my key is located at that this specific directory. So we will log into that SSH terminal. I am going to mobile extend. Now this is my IP address of instance. I open the new section SSH. I provide the remote host IP address. Then I click the advanced. You can use that private key. So I am going with my Terraform location path. Yeah, you can see here this is SSH key generated. Choose the SSH key. Just I am put the OK. Here I am typing as Umundu is my user. This thing I am defining in my Terraform code itself. If you want, you can change the username also. Now I am logging to that instance. Now I am going to that root path. I created the directory called gcs-bucket. Here only I am mounting my bucket into the specific path. I am moving to the path. Just I am testing the file. This file generation I am doing from my shell script. So we can see that bucket level also, whether the file is present or not. I am moving to the GCP console page. Here I am typing the bucket. Yeah, you can see here the bucket is listed. I am entered into the inside the bucket. Yeah, you can see the both file is listed here. Yeah, in this way we can able to mount that bucket file into that VM. That's it. I hope this video will be useful to everyone. Thanks for watching. Bye.